Good morning, everybody, and thank you for having me. So again, Python and Spreadsheets, this is the Canadian edition. I tried to sort of Canadify this presentation, but I wasn't really able to find any sort of good Canadian data. So this is actually, well, not that there's no Canadian data that is good. I wasn't able to find any data that I thought would be good for a Canadian audience. So I'm going to end up giving you all a homework assignment, which is going to be you can take what you learned here and then get your Canada on with those wonderful learnings. So I'm a QA specialist for a startup. I used to do a bunch of other stuff. I'm just going to sort of jump into this. Here at the bottom, this is the GitHub repo where the slides and the code and all that sort of stuff are going to be. I'm going to skip through. I'm not going to focus a whole lot on all of the code, largely because the interesting code in a situation like this is going to be based on your specific use case. I'm going to focus instead on the code that's unique to this library that I'm looking at. So how I got here, I'm going to focus on describing the problem space, and then I'm going to be using this library called OpenPyXL, and I'm going to describe how I'm using that as a solution. And then at the end, I'm going to discuss some of the problems you'll run into if you're trying to work with spreadsheets by way of code. So this you can take a look at if you care about, like, who is Kojo and where did he come from? You can go to my website or just talk to me on Twitter. I'm transitioning here at the top of all my slides, my name and my Twitter handle. So if you use the Twitter, you can reach out to me there and ask me things. I like to try to focus on being able to add new contributors to the Python community, and that's one of the reasons I'm doing a talk like this, because I think it's a good way to bring non-programmers into the Python world by giving them a use case of how Python is actually beneficial to them. Again, I'll be sort of skipping through some of the standard Python stuff, and because the actual interesting code will be based on what you're trying to do in your specific use case, I'll instead focus more on the actual uses of the library, sort of the quirks that happen, the non-standard Python stuff that happen when you're using this library, or in these situations working with spreadsheets. So step one, if you're working with a spreadsheet, is that you have to know your data. You have to be familiar with your data that you're working with. So let's take a look at this data and this problem space. So this problem comes from working with time utilization data. So if you worked in a professional services firm, I've worked for accounting firms, I've worked for engineering firms, one of the things that comes up is this idea of utilization. Are you working on a billable project or are you not working on a billable project? And that if you're working on a billable project, the company can bill those hours out and you are being utilized. If you are not, then you are sometimes called on the bench or you're just a direct overhead expense. And so that's what's happening here. So if we take a look at this data, we got some sort of company logistics. The company's broken up into divisions. Then here, CC is a cost center. And so everyone works in a specific cost center. You're assigned to a cost center based on a job. Your employee number is just your employee ID number. Employee name, as you can see, I've sort of made up these terrible fictionalized names. Who's your manager? And then this DOE and project, those are hours. DOE, direct overhead expense. That means you're not working on a billable project, versus project where you are working on a billable project. And you've got a certain number of hours. These are monthly, aggregated hours for the month. All these numbers add up to 160, just based on 40 hours a week, 4 hours, 4 weeks in a month, 160 hours. So this is the input data that we have. So you get a spreadsheet dump like this, and this is the input data that you have. But the output, it needs to be sorted by function. And so here you've got a basic structure of the company. You've got these cost centers that we saw before, these cost center numbers that really don't make any sense to anybody. And unfortunately, that's, depending on where you work, you might have seen something like that. But if we, each of these functional areas, say like accounting, like engineering, like marketing, will have multiple cost centers. And so they're grouped that way. So you need this output to be sorted by function. So accounting might have these cost centers, engineering might have these cost centers. And so the result that you need is a spreadsheet that looks like this. And so you've got, so this might be, say, from the engineering tab of a spreadsheet. And so here are the people for this cost center, and here are their hours, and then you've got some other calculations here, total hours, DOE utilization percentage. So we can see they're at 79 hours of DOE, that's 49%, 50% being used on a project. And then within a function, you might have multiple cost centers, and so you want this broken out. This is one of the tricks that you have when you're dealing with spreadsheets, is that often you have to have visual output. It needs to look a certain way. It's not just a matter of data processing. Someone wants it to look a certain way. You're generating some sort of report for someone. Almost always because someone's boss's boss likes to look at it this way. And so you have to give them this visual output. And so I'll talk about that a little bit as we go through the presentation. So the original method for doing this, and again, so this is based on something I had to do in a prior job. I would get something like this, but with maybe 500 or 600 different employees. Actually, I started with, no, that's the older version of the presentation. But I'd have maybe 500 to 600 employees, and then I needed to break them out into something that looked like this, but there were 10 to 15 different functions and about 80 different cost centers. And so the original way this was done was using a spreadsheet and just filter for one cost center, copy that data, paste it into a spreadsheet. Filter to the next one, copy, paste. Filter, copy, paste. You feel my pain already, I feel. And so when I took this position, I had started to focus more seriously on improving my Python skills and in looking to making a career transition to being a software developer. I became a professional software developer about 2 years ago, December 2015. And so I started this in like 2013. And when I saw this, I thought, you know what, this is dumb. I'm not going to copy, paste. You know, I know I can do this in code. So I decided to figure out a way to do this. JSON, to the rescue, this is one of the things I had to teach myself. Interestingly, if we go back to this slide, this sort of mapping here, this didn't really exist anywhere. It was basically the only way you knew like what cost centers belonged to what function was by looking at the last report that had been generated. And so in a lot of businesses, the way that, say, the report for the month of August is made is you take the July report, you take all the data out of it, and then you put in the new August data. You copy, paste, and then adjust as is necessary for August. And that's terrible. Don't ever do that. That's why I'm here to help you. You're welcome, Canada. So one of the early things I did was, and actually, in the development process as I was figuring this out, this probably came a little bit later, but one of the things I realized was I needed some sort of mapping like this. Because I needed to know, okay, well, for this quality cost center, this quality functional area, what cost centers are associated? For accounting, what cost centers? For HR, what cost centers are associated with it? This has a couple of advantages. One is that the organization I was working with at this time was going through a lot of flux, and so these mappings might change every month. So maybe HR now is going to report to accounting instead of the HR group. Or maybe this cost center, 55308, it moves from HR to accounting. Or maybe this 52A11 moves from quality to project management. And so being able to have this mapping in one place, in one file, made things simpler. But it also makes our code work more simply. So we've got the JSON mapping. And then we get into the actual code. So what are we doing here? I've got to take that input. I've got to create some sort of a construct in Python. And then I have to output that to a spreadsheet. So I'm using this library, OpenPyXL. And so you can see here I'm importing it. I'm importing this load workbook function and then this workbook module. And so here, this workbook equals load workbook. This headcount summary XLSX, this is the first input spreadsheet that I showed you. And so I'm loading that spreadsheet in, and I'm creating this workbook object here. And then here for source, my source data, saying workbook.getSheet by name, and I'm getting a specific spreadsheet out of that workbook. And that brings us to this next thing about OpenPyXL data types and specifics about spreadsheets. So people sort of use the term spreadsheet fairly loosely. What you actually have is if someone gives you like an XLS file or an XLSX file, that's actually called a workbook. And then each specific tab inside that workbook is a worksheet. And then that worksheet, that individual spreadsheet is made up of cells. And I point those out here not to be pedantic, but because this is also how OpenPyXL names its data objects. And so it will give you a new data type called workbook that has certain attributes, and another data type called worksheet that has certain specific attributes, and a data type called cell. And that ends up being very powerful because it lets you pull not just the data from the spreadsheet, but also a lot of associated metadata. I won't get into a tremendous amount of that, but it's something to touch on. Also, I would point out that the OpenPyXL documentation, which is hosted on Read the Docs. Where is Eric? It's hosted on Read the Docs. Excellent documentation. There's a lot of detail that you can get into here, but these are sort of the basic things we look at. So I'm creating this source construct here, which is the data from this monthly headcount summary that input spreadsheet that we saw earlier. And this is what I'll be working with, this source object. And here now, I'm creating a basic header. Basically, this source.rows, this is unique to OpenPyXL. So source is a worksheet. Source.rows gives me the rows from that worksheet, each row of data. But it returns a generator object. And so I'm using the next here to just pull the first row off. In this case, that row is the header, which gives you the descriptions of each of the data columns. And I'm just appending each of those values to this header construct here, header and empty list. Cell.value, so again, we see source is a worksheet object. Here, for cell in this .rows, it's going to give me a cell object. And so here, each of these cells is a cell type object. So cell.value gives you the actual specific data value that's in that cell. You can also do other things. You can get the formatting for the cell. You can get the text color, all sorts of other things. But here, I'm focusing on just the value. So here we've got the cell object and then the worksheet object. And then I'm adding some new things to it. These total hours calculation, so space for the total hours, the utilization percentages for DOE and for project. So then I'm going to create these sort of functional groups. And here I'm opening my JSON file. This is where that JSON is stored. I'm calling it this department dictionary because those functional groups, I'm calling those departments. And then I make this empty dictionary. And I'm creating a dictionary where the key for each item in the dictionary is going to be the name of that department. So if we go back to the JSON file, accounting, HR, engineering, what have you. And then the value is going to be this list of each employee who belongs to that functional area based on their cost center. And so you see this functional table function that's being called here. That's what this table does. This is the doc string from that function. You input a list of cost centers that make up a specific functional group, and then you get back a list of lists where each of those inner lists is an employee. And again, here, there's not a whole lot of magic happening. But again, for row in source.row, so again, source is that worksheet object. So for every row in that worksheet, I'm going through and I'm appending those values to this temporal construct that I'm making. And then that temporary row is being appended. Let's see, well, so here, I'm just pulling the data, the values that exist in the spreadsheet and adding them to this temporary row construct. And so I'm taking the data from the spreadsheet and putting it into this Python construct, but then I'm making some changes to it. So initially, you end up with 7 data items that come from the spreadsheet, but then I'm adding some other things. Here, I'm doing the calculation to find out, okay, what are the total hours? And then I'm doing another calculation to find out, and so here the total hours are just the last 2 items. Here I am appending the utilization percentages for DOE and for project by just grabbing the last items. And as the list is getting longer, I'm having to do some negative indexing. But here I'm calculating the utilization and the overhead and the project utilization percentages here, and then adding them to that temp row. And then that temp row is being appended to this temporary table. And so that's what's giving me these basically spreadsheet type objects in memory. So this is done. So once I've sort of looped through all the keys that are in that JSON thing, I've got this dictionary that has all that data that I need in it. But now I need to actually create, so I have a Python thing that I can work with. But now I need an actual Excel thing that I can work with because that's kind of the point. So here I create this target, which is of type workbook. And again, that's why that was important later, that was important earlier. And then I just give it a file name. And so I'm calling it head count by function. And then I do another looping process where I'm going to loop through that sheetDict construct. And for every key, I'm going to use this create tabs function, where I'm going to pass it the value of the key, and then the key itself, the key here being the name of that department, which will also end up being the name of the tab on the spreadsheet. And so we'll take a look at this create tabs function. And there's the doc string for that. Again, here I'm making the construct that's actually going to be written to the Excel sheet. And so here, worksheet is this target, again, target being the workbook object I created before, target.createSheet, and I give it a name, that tab name that I passed in, and And this 0 index means that it's going to be the first one. And so every new sheet I make, I just want it to be the first one. And then here, this spacer that I create. Spacer is none. I'm basically just making an empty row, sort of like the header. And that's because I'm going to be creating this visual output. And that's why, and this is another sort of weird thing that happens because you're trying to create visual output. So I need the spacer row to go between each of the cost centers. Skipping this head count sorted thing where I do some fancy sorting. It's sorting. You can sort in your own way as you see fit. But basically, I'm taking this func table thing that I created earlier and sorting it a little bit. But here, this is where the visual formatted output comes into play. So I've got this information sorted, this head count information sorted, and I'm getting this row index for it. And then here's where I'm doing some things based on creating visual output. So if I end up with, if the row index for this thing is 0, if it's the first row, then I need to, and let me see, let me jump back to, there we go. So I need my output to look like this. So for each cost center, each time the cost center changes, for a new cost center, I need a header, and then I need the data, and then I need a space, and then I need the header for the next cost center. And so that's where, this is terrible, I'm sorry. That's where this is happening. So if I'm ending up with the first row, then I'm going to append the header and then append the data row. Now, if that row index is not the first in the row, and if the cost center on this row is the same as the one before it, then just append that row, where, again, each row is this data that we've created for the individual person. And so here I'm just appending a new row. But then if the cost center is different from the prior row, then it's a new cost center, and so I need to add in the spacer, and then put in the header, and then add in the data row itself. So here you can see we're sort of comparing the row index to the previous row index, and this index 1 is the actual cost center data, and let me see. There we go. So if we take a look here, index 1, the cost center. And so I'm comparing, okay, is the cost center in this row I'm looking at now, is it the same as the cost center before, or is it different from the cost center before? And based on that, I'm deciding, do I just add in the rows data, or do I add in a spacer, or do I add in a header, that sort of thing. And again, this is all done purely because I need the output to look a certain way. And so this is kind of where the magic is happening, because I need this spreadsheet to look a certain way. The most important line of code here is this, because this target.save, if you don't do this, you don't have an Excel file when you're done. So you have this wonderful Python construct, and that's all nice and wonderful or what have you, but if the point of this is you need to be able to create a spreadsheet to give to somebody, you don't have one until you do this. And so the most important thing here. And again, this is a specific OpenPyXL thing. So I've got this workbook object, and I can save it, and there's the magic. And that's sort of a simplified overview, but that's really the core meat of what happens here. You pull in the data from the spreadsheet, you process it the way you need, and then you have to generate this output in the way that you need. Sometimes it will be based on visual formatting, sometimes it won't. And then that's, again, why we get into the why you hate spreadsheets. So I often say spreadsheets are terrible. The truth is there are no terrible spreadsheets. There are terrible people who use spreadsheets. And they use them in terrible ways, so shame on those people. Don't be those people. One of the big problems that comes up is that spreadsheets are often used as a visual medium, and like I said, oftentimes a spreadsheet is formatted because someone's boss or someone's boss's boss wants to see something look a certain way. And so if all you ever get as input is just straightforward structured data, and your output only needs to be straightforward structured data, it's fairly straightforward, it's fairly simple. The reality is you often won't get that. You'll often get either input, or you'll have an input or an output requirement where something is done visually. And so you have to sort of find ways to work around those things, or just generally unstructured input data, that sort of thing. So this is where things can become a little more problematic, but you have to find more creative ways to work around those solutions. You can also make new friends, and so one of the things I like to try to do is try to find new ways to add contributors to the community. And so if you start looking at tasks like this wherever you work, would you be able to maybe help encourage a coworker to start learning a little bit of development by finding a way to get them to, helping them simplify a process? So this process that I described with the manual copy and paste, it used to be like a 6 to 8 hour process. And with a couple of scripts, with this script and then another one that I wrote before that did some transformations, it all happens in about 120 seconds. And so, lots of people want to be unique snowflakes and don't want to have to standardize their data. But if you can reduce the time, a 90% reduction in time might make people willing to, do a little standardization. So it's just something to consider. Again, every use case is different, which is one of the reasons I didn't focus too much on the code, because the specific code you write will be based on your use case and your data. But it's something to think about, something to consider. I can't remember whose talk it was yesterday. Thomas Ballinger's talk about working with, dealing with your coworkers and understanding that if they come from Java or from C++ or from somewhere else, how can you sort of reach out to them? How can you sort of be a bridge? This is a situation of that type. Also here, this is something I just didn't have time to cover, but all these cell style attributes, you can use these to read data. So if you have like a spreadsheet where a profit number is green or a loss number is red, you can look for those things, or if you need that output to be a certain way, or you need borders or certain styling, you can do all of that with like, cell dot whatever. So there are a lot of things you can look at there, so please take a look at the documentation. And that's all I've got. If you have any questions for me, I am Transition on Twitter, my website, my blog, which is not terribly updated, but I'm doing what I can. And this is the repo. My GitHub username is just my first and last name. And the code and the slides will be here. And if you have any questions, feel free to reach me on the internet, and I'll be here. I'm the very tall gentleman in the red hat, and so you'll be able to see me. So thank you for your time and your attention.